Today is about the properties of alkane. Alkane is sometimes referred to as paraffin, a word derived from the Latin param affinis, meaning little affinity. This term aptly describes their behavior, for alkanes show little chemical affinity for other substances and are chemically inert to most laboratory reagents. They are also relatively inert biologically and are not often involved in the chemistry of living organisms. Alkane does, however, react with oxygen, halogens, and a few other substances under appropriate conditions. Reaction with oxygen occurs during combustion in an engine or furnace when an alkane is used as a fuel. Carbon dioxide and water are formed as products, and a large amount of heat is released. For example, a natural gas called methane reacts with oxygen according to the equation. The reaction of an alkane with chlorine gas occurs when a mixture of the two is irradiated with ultraviolet light. Depending on the time allowed and the relative amounts of the two reactants, a sequential substitution of the alkane hydrogen atoms by chlorine occurs, leading to a mixture of chlorinated products. For instances, methane reacts with chlorine gas to produce a mixture of chloromethane, dichloromethane, trichloromethane, and tetrachloromethane. Alkane shows regular increases in both boiling point and melting point as molecular weight increases, an effect due to the presence of weak dispersion forces between molecules. Only when sufficient energy is applied to overcome these forces does the solid melt or liquid boil. As you might expect, dispersion forces increase as molecule size increases, accounting for the higher melting and boiling points of larger alkane. Another effect seen in alkane is that increased branching lowers an alkane's boiling point. Branched chain alkane are lower boiling because they are more nearly spherical than straight chain alkane, have smaller surface areas, and consequently have smaller dispersion forces.